Hello, everybody. Welcome to the session 2 of the text mining practicum. I appreciate all of you who are able to attend despite the campus shutdown. I apologize for giving the wrong time on the invite. What I had done is included you on a meeting invite that I meant just for myself. I started my own meeting invite an hour early just to block off time to get prepared for today. I mistakenly didn't update that before I added everyone to it. So again, my apologies for that. The the next text mining practicum, I'll get the time correct. I promise. Also, the next text mining practicum session will be in 2 weeks. Next Friday is Good Friday, and that is a university holiday. So I will not offer it on the university holiday. Look for the look for the invite to be for April 17th. For those of you still in Dallas, I was checking the weather out. I noticed I'm right by my window. I guess you can see windows in the background. Nice and sunny outside. But then we have some rain again early afternoon, and oh my gosh, temperatures plummet to the 40s. It's getting cold. If you want to get outside, well, sorry, you can't. You're stuck in the text mining practicum. As always, please feel free to interrupt me if you have questions. Unmute yourself is the best way of doing it. You can also chat to me through the chat feature, and what I see is a presenter view. On your view, you can see a button that says raise hand. If I see that you've raised your hand, I'll stop and acknowledge you. However, you still might need to unmute yourself and let me know. I'll also be looking over at I have a monitor over here that I'm looking at most of the time, but my laptop's over here. That's why for a lot of the presentation, I'll be looking like this. Not because I hate you, just because I have a disconnect between where my camera is and where the monitor is I need to look at. Today's agenda, we're going to finish up session 1. I had to stop at line 90, so we'll catch up to where we left off on session 1 and then finish it. Then we'll do a quick review of the concepts we have learned in session 1. Then I'll show you a site that has a bunch of great R cheat sheets. I'll show what this means. Next will be a comment about Stack Overflow and online documentation. Then finally, we'll dive into chapter 2. Chapter 1 of, when I say chapter 1, I mean chapter 1 of text mining with R. And that's about the tidy text format. The tidy text format is a recommended format that you get your data into to facilitate further analysis. This format is great for text analytics. It's also great for many kinds of uses of R, not just text. If you are analyzing more numerical data, say, or just statistics, anything, the tidy text format is often a good format for you. It's important to understand this no matter what your intended uses of R will be. Chapter 2 is sentiment analysis. The idea is once we have gotten our materials into a tidy format, then the next step, or a possible next step if you would like, is to check the sentiment of the text that we are reviewing. We'll have some interesting findings from that. Whoops, let's review. Here it is. I think someone asked me prior time to zoom in a little bit. If I need to zoom in anymore, please let me know. I chose a zoom level, hopefully to help you, but please interrupt me if the zoom level is not right. What I will do is I'll briefly run through these lines 1 through 90 and remind you what's going on, but I'm not going to get in depth on them because we went over that with the first session. And by the way, if you missed the first session, I shared a link to the video from the first session. You can catch up that way. I'm also recording a video of today's session. You may review it later if you'd like. Again, please interrupt me if I am not explaining something well. I want to help you. I want you to learn. These commands on lines 4 and 5, they load libraries that we will use. Libraries are collections of functions and data that can help us with our use of the software. These first few lines, we gave an example of unnesting this poem into the tidy text format, and the tidy text format has each piece of data we are studying as its own row in a table. In this case, our intent is to analyze words, so we have split this poem into where each row has one word. I'll talk about that a little bit more before we go on to chapter 2. The Jane Austen R library, that library mainly is to contain data that is the Jane Austen books that you can use for experimental analysis. These next few lines, excuse me, we separate the Jane Austen book into chapters, and we then remove stop words from the Jane Austen books. Stop words are words that we don't believe have much value to our analysis, like a, and, the, and many others. So we remove them before we do formal analysis work. Here's where we are making counts of the words, make a pretty plot that shows the most common words in the book. Next, we explore the Gutenberg R library. Project Gutenberg is a great website that has thousands of complete free books available. These are books where the US copyright has expired, and I think there are cases where there are works where the author has said, I'm done with copyright, I'm going to release it so that Gutenberg can host it. These are copyright-free books that you are free to download and analyze and read or do whatever you want. In our case, excuse me, we use the Gutenberg R library to download books based off their ID. What does this ID mean? If you go sample some random book, and then whatever this book is, 2 by Tricks, whatever that is, there's an ID number for the book. All you have to do is reference that number in this Gutenberg download command, and whoops, and then that will be the book that you are downloading. Jin, you ask, are you going to share or post the recording after today's session? Yes, I will. I'm recording right now. Zoom's kind of funny. Zoom is recording this or saving this session in a format that's not highly processed. So as soon as we're done with the Zoom meeting, a little bit before lunchtime, I'll stop the meeting, and it'll probably take about 30 minutes to process the video file. Then once it's done processing the video file, I will upload it to a server and then share the link with you so you can watch it on your own. Our next steps is we convert the H.G. Wells books. These 4 IDs correspond to H.G. Wells books. We convert it into a tidy format so that we can do analysis. We also download Charlotte Bronte's works, do the same thing, convert it to a tidy format. And we went, whoops. Actually, line 90, I believe, is where we need to pick back up. That's what I have in my notes. Yep, line 90. Well, let's start there. Let me back up to give some context to line 90. Again, the Gutenberg R library. We loaded that so we can download books from Project Gutenberg. We have loaded the 4 books in Project Gutenberg corresponding to H.G. Wells, and they are all saved into this H.G. Wells. Where is it? Did not run that line? Let's try it again. Looks like it didn't run that line. There it is. Here's the H.G. Wells tibble. And what happens is each row has the ID of the book we are pulling from, and then it has the text of the book line by line. If I scroll down, the ID number changes. Remember, we got books 35, 36, 52, 30, and 159. If we were to scroll through this whole thing, there's 159, and there's 5230. So there's the 4 books. We downloaded 4 books. They are in a tibble, a data frame or tibble in our program, and then we are freely able to analyze it. Next is we create a tidy format out of those books. This is not a tidy format yet because we do not have one observation per row. You know what? I'm going to pause and go right now. I think I do need to explain the tidy format a little bit. I glossed over it at the last class because we got kind of in a rush after I covered the basics of R. The tidy text format are these three things. The important thing is each observation is a row in the table. And by each observation is a row, what I mean is that what are you analyzing? Think about what you are trying to analyze. In this case, I want to analyze words in the book. Therefore, each observation needs to be a word. And I need to assure that each row of my table represents one word in the book. Each variable that I could potentially analyze is a column. And that comes to light in what we did with the tidy books table, where each row does correspond to the word, which is the main thing I want to analyze, but the other columns represent other variables that could be relevant to my analysis. In this case, line number, chapter number, word, and book title. Each variable is a column, each observation is a row, and each type of observational unit is a table. And in this case, the observational unit is kind of like a book, you could say. The unit would be some meaningful grouping of your variables, or of your observations, I'm sorry. That is the essence of the tidy format, and that is, again, what we are going for with what we are doing with, or sorry, that is what we are going for with what we did last time with the Jane Austen works, and it's what we are doing now with the H.G. Wells and Charlotte Bronte text. By the way, you may notice that we sourced the information for Jane Austen from a library inside of R. We sourced the information for H.G. Wells and Charlotte Bronte from something totally different. And you can do that with R. You don't have to source all your data from the same location. You can source it from wherever you want, as long as it comes together into some kind of tidy format that enables you to analyze it with R. It's fine to get it from wherever, and that's pretty common. Okay, where was I? Here we go. So we downloaded the H.G. Wells books, and they are again saved in this table named H.G. Wells, and we have line by line of these books. The next is we need to convert it into a tidy format. We discussed unnest tokens at the last class. Let me quickly remind you of the pipe command. What the pipe command does is it takes whatever you have on the left side of the pipe. It does whatever it does, operations on the left side. It takes the output of that, then shoves it into the right side. In this case, it takes the HG Wells, and all that does is lift up the HG Wells data and does nothing, no processing. Simply gets the HG Wells data, and then takes the output of that command, which in this case again is the HG Wells data, then shoves it into the next command. This command then accepts the HG Wells data, does the unnesting on it, and its output is a unnested version of the HG Wells tibble. If you highlight text and then press run, only that text you highlighted is what is run. I will click run, and down here you see that the output is not like this. We took this, which has one line of text per row, and we converted it into a new tibble that has one word per row. And that's what unnesting does. With this unnest tokens command, the first argument is the name of the column we wish to create that has the unnested data, right here, word, whoops, there it is. That word is the name of the column we wish to create. And the second argument is the name of the column we wish to get the information from the original tibble, which in this case is text. Whoops, see right here, text. So we're pulling the information out of the text column, unnesting it into words, and then throwing it into a new column named word. What this is the output of the unnest token command. Let's look back at our pipe. The output of that command then gets piped into the anti-join command. An anti-join command is where we take we take this data down here, we anti-join it with the stop words table, which means that the words in here that match the stop words table get removed. That is what an anti-join is. If I run all three of these commands, before I do that, you see the word the, by, I think individual letters make it removed too. The, I think I is removed. Let's see what happens. Yep. See what we get now that we have removed stop words? We have removed words that we believe are superfluous to the analysis. Now I will run line 73 through 75. And when I do that, what you see here is saved. Remember, the assignment operator is saved into a table or an object actually called tidy underscore HG Wells. Now, the tidy underscore HG Wells object contains the HG Wells text in a tidy format and with the stop words removed. Here is where we will do a count, like a preliminary analysis to say what are the most common words. What this pipe does is it takes that tidy underscore HG Wells object we just made and it pipes it into the count command. And the in the count command, we're telling it to count the content of the word column and give us a count of the number of instances of each word in the word column. Time is the most common word in all four of the H.G. Wells books that we are studying. By the way, sort equals true. That means sort it in descending order by highest count. If I don't add sort equals true, let's see what happens. It just seems to be, looks like it alphabetizes the word column and it doesn't sort by in, but that's not useful to us. And in whatever it is using to alphabetize, the underscore character goes first. It goes before any letters. That's why you see these words at the very beginning. Another thing you will notice is some of these words are really stop words. We probably should have removed them. I'm just using the examples in the textbook directly, but I like that we're using them because I can expose some thinking about some errors that we should have taken care of. What we really should have done is removed. Let me back up. What we should have done is after we unnested all the words, the next step should have been to remove all underscores and then do stop words or remove stop words, because am is not the same as underscore am underscore. Because of those extra characters, wow, suddenly it's bright back here. Because of the extra characters, the anti-join did not realize that we need to, or it did not match this. It did not realize we need to take away that word. That's an example of where you need to really know how this functionality works so that when it's your turn to analyze your data and clean it up, you can be assured you're really getting the right kind of clean data. I'll go a little bit more quickly. Whoops, let me restore that original word. Okay. We're going to do the same thing to the Charlotte Bronte text. Here we are downloading 5 Charlotte Bronte books from Project Gutenberg, done. Next, we unnest and remove stop words. And then next, we get a count of the words. Oh, interesting. The most frequent word in Charlotte Bronte is also time. However, look at how would you characterize, let's look at something. Here are the 10 most frequent words in Charlotte Bronte's works. Look at those words. Let's go back up and look at the H.G. Wells 10 most frequent words. Okay, already I see a difference in tone between the 10 most frequent words. This is highly preliminary analysis, but it does suggest that there's a difference in the topics or tone between Charlotte Bronte's works and H.G. Wells's works. And if you've read these books, yeah, you'll get it. Now we're going to compare the Jane Austen words to the Charlotte Bronte and H.G. Wells words. I have to unpack a little bit of the statement. This is a fairly complex command. I'm going to unpack it bit by bit, but I'm going to take it over to a separate R file to explain this. And please pay attention because it's important that you understand how this works. First thing is when you look at a complex command, break it up into each individual command in the pipe. And do that by looking for the pipe operator. That the pipe operator is what separates all of the commands in the pipe. Here we see the first pipe operator is after this command. So what is this command doing? It is the bind rows function. What the bind rows function does is it takes all the tibbles you specify, tibble, comma, tibble, comma, tibble, and it slaps them one on the bottom of the next one. That's all it does. It stitches them together. What are the three tibbles that we are slapping together? It's going to be the output of these three commands, of these three mutate commands. This is going to be the first tibble. This is going to be the second tibble. And this is going to be the third tibble. Remember that a function call, the comma is what separates the arguments in the function call. So the comma here, my spacing's a little bit weird. So comma here, and then the last command. These two commas separate the three arguments. And again, those three arguments are represent tibbles that we're going to slap one on the bottom of the other. What is the first tibble? It is the output of the mutate command. What does mutate do? It adds a column to a tibble. That's all that mutate does. The word looks scary. The concept is easy. Again, it just adds a column. It's like if you were in Excel and you right-click Insert on one of the columns at the top, it just adds a column. That's all we're doing here. We are taking the tidy Bronte tibble. I'll close some of these out so that we can just see the data I'm talking about. We give the mutate command the tidy Bronte tibble, and we then add a column named author, and we set the author column, we set its value equal to Bronte sisters. This question mark here, this is because of, this is kind of esoteric. It is because of a encoding issue. I used the E in Bronte has the two dots on top of it. So in the file, I used the correct character, the E with the two dots, but RStudio is having a little bit of trouble understanding it. So it displays the question mark instead. It's something called UTF encoding, and I don't think that the editor likes UTF encoding, but whatever. I am highlighting just that one command so that you can see its output. And there it is. We still have the Gutenberg, the Gutenberg ID column, the word column, and now we added the author column. We're doing the same to H.G. Wells, and we're doing the same to Jane Austen. Why are we doing this? Remember that bind rows just merges tibbles together, one on top of each other. If we did not add an author column, how would we know that this part of the merged tibble represents Charlotte Bronte? The answer is we wouldn't. So we have to add a new column named author and set it equal to Bronte sisters, not because of any rule, but because I want to know. I want to know which book each of these came from. The output of this first mutate command then is this: Gutenberg ID, word, author. Here you will see three other columns called book, line number, and chapter. What's going on there is the tidy books tibble has some columns, book, line number, and chapter. It has some columns that the Tidy, Bronte, and H.G. Wells tables don't have. So in that case, in the merged table, there obviously can only be one set of columns for the whole tibble. So if the original tibble that got merged didn't have the columns, it still has to add them, but it puts NA for all of its values, and NA means not available. We'll discuss NA more, I think, on class 4. It has some interesting properties, but it mainly means not available. It's R's way of saying, I don't know what was meant there. I'm just putting something here so you'll know I don't know. That's all it means. Again, the output of the highlighted bind rows command are the Bronte, H.G. Wells, and Jane Austen tibbles. We've slapped them one on top of the other, and we added a column named author so that we can remember which author we are talking to. Sorry, which author we are analyzing. The next command, so the output of that command is this here, shoved into the pipe, which then gives it to this command. Hey, it's another mutate command. We know what that does now. Remember that mutate creates a new column. In this case, we are creating a new column named word. Don't get too caught up on this. This is the string extract function. It uses a regular expression. What I would like to explain is it is removing the underscores. Let me run just these first two commands. You see the underscores down here? Now they're gone. That's all it's doing. It's going through the word column and removing the underscores. One thing to note about mutate is if the name of the column that if the name of the new column that we are creating is the same as a column that already exists, then what you're really doing is you are replacing the existing column with the new column. In this case, we are replacing the original word column, which has words with underscores, with a new word column that has no underscores. That's all we're doing. Next is we take the output of these first two commands in the pipe and give it to count. And in this case, count has two arguments, author and word. That means we are counting by all unique combinations of author and word. Let's see what happens. There we go. The Bronte sisters, and specifically the Bronte sisters, use the word abandon 23 times. That's now what we have. What's the argument? Just a second, I forget. Yeah, sort equals true. I'm going to add sort equals true briefly. The most common words among all three authors, but unique to the author. The first is Jane Austen's use of miss is the most common word. And what I'm seeing here is the first 10 most common words used by a given author. Notice that H.G. Wells doesn't show in here. This is a highly preliminary analysis. We need to do some more adjustment of the data to really create a conclusion. But this kind of suggests that the Jane Austen and Charlotte Bronte were more likely to reuse words than H.G. Wells. But this is very highly preliminary analysis. We need to do more. A better measure could be count of this particular word divided by all words that author used. It's still interesting to see that as just, okay, now I understand the data a little bit better. Let me remove that sorting. Next, we're going to group by the author. Does anyone remember what group by does? Unmute yourself and yell it out if you do. Don't everyone talk all at once. No one remembers.
Isn't that how we make multiple files become one data set? So if we want H.G. Wells, the Bronte sisters, and Austen grouped together for analysis. Or wait, grouping their books together. So, wait a minute.
You're on the right track.
The invisible lines.
Yes, you're on the right. Yes. Both of you are on the right track. And so what group by does, thanks to both of you for mentioning that. What group by does is it groups the tibble based on the unique values in the column that you specified. And what that means, and why do you do that, is because some functions are sensitive to the grouping and they will operate only within the group. And the sum function is one of those. Because we have now grouped this by author, then the next line, this mutate, let me unpack this a little bit. We're creating a new column called proportion. We are then taking the n, which is right here, and dividing it by the sum of the n column. However, because we have grouped it by author, then this sum will only sum up with the n column within a unique author. When we calculate this new proportion column for row 1, it will take 8 and then divide it by the sum of the n column only for columns for rows that have Bronte sisters as the author. Again, that's because we grouped this table by author. Many functions are in the tidyverse are sensitive to grouping, and this can be very useful to you. The output at this point is this. And you'll notice the proportion column is a very tiny number because here we're taking 8 and we're dividing by some number that's well into the thousands. Still, this does give us useful information about the proportional prevalence of these words for a given author. The next command is a select command. This select command inherits from SQL. All it does normally is defines the columns that it will be kept. So normal use of select is you name the columns you would like to keep. An alternate use of select is if you put a minus in front of a column name, then you are specifying the columns you'd like to get rid of instead. In this case, we're saying just get rid of the n column. And see there's an n column here. Now I'm going to rerun this, but include that select statement. The n column is gone. That's all that select does in this case. Okay, next is spread. Right now, this data is in a tidy format. We have one observation per row, and each column is a separate variable. Spread will undo the tidy format a little bit. It will spread some of the data out. And what we're telling it is find all unique values in the author column. And for each unique value in the author column, we're going to create a new column for it. In this case, we have 3 books. So, 3 authors. So the author column right now is Bronte sisters, H.G. Wells, and Jane Austen. And that's because we made these up here. What we will then do, because we are spreading by author, we're going to create a Bronte sisters column, a Bronte sisters column, an H.G. Wells column, and a Jane Austen column. Here, we are telling it to put whatever value was in the proportion column. That's the value that you're going to insert into the value for these 3 new columns we are creating. I'll run this. There we go. See that the proportion column is gone now? In fact, the proportion column and author columns are gone because we spread those 2 out. We took the author column, found all unique values, made new columns that correspond to those unique values, And for the value we put in there, we lifted what was in the proportion column. Here's an example. For Bronte sisters, let's go back up here. Bronte sisters, for the word A, the value was something, 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 319. Bronte sisters, the word A, again, 319. There's a reason we're doing this, and I'll show you after the next command. The next command is gather. If spread undoes the tidy format, gather kind of brings it back into a tidy format. I say kind of, I'm using weasel words because that's not totally what's going on, but it's an analogy. Gather here is going to bring it closer to a tidy format. And what happens here is we are creating, sorry, let me just run this so you can see it. Oh no, I'm gonna fix this. It's complaining about the use of the weird character. Yes. What we have done is we have taken, this is a shorthand notation. You see that sequence operator? Remember that normally sequence means if you have two numbers with a sequence operator, it means start with the first number and count up until you get to the last number. That's normally what sequence means. Sometimes sequence is also a shortcut when you are specifying columns, where you specify the first column, you specify the last column. If you put the sequence operator between them, it means take that first column and the last column and every column between them and do something on them. In this case, this is kind of silly that they did this, but they're taking the Bronte sisters column, the H.G. Wells column, and everything between them. However, in this case, there's nothing between them. So that statement literally means just those two columns. Anyway, we're taking these two columns and we're going to gather them. We will make a new column called author. See, right now there's no author column in the table. We make a new column called author. Its values are going to be the names of the columns that we are gathering. And there will also be a new column called proportion. And whatever was the value in these two columns will now, it's Bronte sisters to H.G. Wells, is these two columns. Sorry, these two columns are what we are gathering. The value that was in these two columns now will go into a new column named proportion. The output of that is right here. Note that we did not tell it to gather with the Jane Austen column. We only told it to gather the Bronte sisters and the H.G. Wells columns. And the values that were here or here that were in these two columns is now in this new proportion column. What do we have? We go back to what the chapter says. We're trying to compare Jane Austen to the other two authors. To help facilitate that comparison, we have, with these commands, we have made it so that there is a Jane Austen column, and now we're comparing her works directly to the Bronte sisters, and we're comparing to H.G. Wells. This is kind of complicated. I understand if you don't get this. Just trust me, that's what we're trying to do here, is structure our data to make our analysis more straightforward. This is what I just unpacked for you. I'm going to run this and save it. Whoops, I need to fix these UTF characters.
So is H.G. Wells not in that in the gather table because it takes the larger proportion?
Good question. H.G. Wells is not in the gathered table because those are one of the two columns we are gathering. It is in there. Let me show you something different. So frequency is the object we are saving the output of all this into, which includes the gathering at the end. Let's look at frequency. I think it's all simply about alphabetation. At the top, we have Bronte sisters. If I go way down, There's H.G. Wells. It's just you just saw an artifact of alphabetizing this. When we viewed it here, you just happen to see the first 10 rows, which are only going to be the Bronte sisters. Does that make more sense?
But if H.G. Wells had the word a and a proportion, where did that go?
I believe that this resulting table is sorted by author. We would have to go to the top. Let's see if I can find it without spending a lot of time.
Oh, okay.
See, it's sorted by author first and then by word second. So if I get to the end of Charlotte Bronte, here we go. Ah. It goes blank because it's taken the user interfaces. I'm going faster than what the user interface can catch up. Here we go, close. Here it is. Here's
Okay.
where it switches from Bronte sisters to H.G. Wells. So this table is primarily sorted by author, then secondarily sorted by word. Does that make more sense?
Yeah.
Okay,
Thanks.
sure. Now we're going to graph this. Don't worry too much about this library scales or the ggplot command. I'll explain ggplot more on the next session, and I do recommend attendance at the next session. It's important that you are able to describe what you are analyzing, and ggplot is an integral part of that. There is no substitute for knowing ggplot. There we go. What we have now generated is a plot of the relationship between the frequency, or I guess the proportion of occurrence of words between Charlotte Bronte and Jane Austen, and between H.G. Wells and Jane Austen. Remember that our objective, per my notes here, was to compare Jane Austen's word use, I'll write this here, to the other authors. That was our goal, and that is what these two plots are helping us with. This, remember that the value that we are using for this graph is the proportion of all of the author's words this particular word takes up. So there is a big correlation between the frequency of the use of the word miss between the Bronte sisters and Jane Austen. However, in H.G. Wells, the percentage, the proportion of use of miss is the same for Jane Austen, but it's a lot less for H.G. Wells. Another thing we notice is with the left diagram, we see a tighter clustering of the dots, and that suggests a greater correspondence of, I'm using correspondence is probably not the right word. We see a tighter correlation of word use between Jane Austen and Bronte sisters, whereas the dots on the right side seem more spread out. So there is not as tight of a correlation of word use between H.G. Wells and Jane Austen. And if you've read those books, given the topics that they wrote about, that shouldn't be surprising. Okay, I'm going to stop there for chapter 1 of text mining with R. What we have done is we started with some raw data, we converted it into the tidy text format, and we did this for 3 different authors of books. And the end result was we were able to determine how closely Jane Austen's word use in her books relates to the word use of the Bronte sisters and H.G. Wells. And what we see is a scatter plot that suggests a tighter correlation of word use between the Bronte sisters and Jane Austen's versus Jane Austen and H.G. Wells. That is it for chapter 1. Let's run to the chapter 1 review real quick, and then we'll go into sentiment analysis, which is actually even more interesting. Jin Yu, I missed your question about how you make R understand it. I apologize. If you need to ask that, feel free to chat or unmute yourself. Sorry, it looks like you asked that about 20 minutes ago, and I totally missed the chat. Okay, let's review the major concepts from session 1. R is simply the programming language that we are using. RStudio is the integrated development environment. It's what makes it nice to program with R. If you didn't have RStudio, then what you would have to use is a really clunky interface that is native with R that is not fun at all to program in. So this is what you'd be programming in. It doesn't really have a strong concept of R files. I think it's a weak concept of R files, but it's kludgy, it's not fun, it's hard to use. RStudio is a lot nicer to use than this garbagey old interface. Next is an object. What is an object? It's what all your data gets saved into. If you don't save your data into an object, then it goes poof, disappears as soon as R is done processing it. If you want to refer back to that information, save it into an object. Next is the assignment operator, the arrow. I'm highlighting that because in most languages, you will see the equals used for an assignment operator. And what's the assignment operator? It is what tells R to store data into an object. Usually it's object name equals data. Or in R's case, object name, arrow, data. And arrow is the less than symbol and then the dash symbol. Next is a vector. The vector is the most basic data type in R. The vector is a series of chunks or pieces of data that are all of the same type. Series is actually not technically the right word, but it's just a set of data, pieces of data that are all the same type. And by same type, they're all numbers, or they're all strings, or they're all booleans, whatever. They got to be the same type. Tibble. Tibble is R's equivalent to roughly an Excel spreadsheet. It's a table of data where each column has a consistent data type. So each column is like a vector, where all the values are a character string, all the values are a number, something else. They all got to be consistent, but it is like an Excel spreadsheet, and each of the columns can have a name. A function is it's like a series of commands that you can run just by invoking the function name. A library is a collection of, I probably should put package there. Let me change the wording on that one. A package is there we go. A package is a collection of functions and data that help you with your program. They are what other people have done for you. When I load the tidyverse package, whoops, I closed that out. Well, we'll go to chapter 2. When you load a package using the library command, then you are making all of the spiffy functionality of that package available to you when you're when you're creating or running your script. A package is the collection of functions and data. The library command is how you load that package in your script so that its spiffy stuff is available to you. Next is unnest tokens. That is where, in our use of it, we have given it text data, and we gave it text data that was rows of or lines of text in a book. We used unnest tokens to take that text data and split it into one word per row in our Tibble. Unnest tokens was the main thing that helped us take our unstructured or semi-structured data and convert it into the right kind of structure in the tidy format so that we could analyze it. The tidy format, again, is one observation per row. And what is an observation? Is the essential piece of data you're wanting to analyze. In our case, we wanted to analyze words, so we need to separate it into one word per row. Next is the pipe operator. It's a great operator that allows you to chain commands together, and the output of the prior command in the pipe gets spat into the next command. It can, I say, this is a weasel word again, it can help you simplify your code. However, there are cases where if you go too far with the pipe command and just chain way too much together, it can make it confusing. There's a balance in everything. Mutate looks scary. All it does is it adds columns to your table. That's all it does. Don't let it be scary. Group by and ungroup. Group by groups your table by the unique values in the column or columns that you give it. Earlier, I said invisible lines as a teaching example. That kind of makes sense when your table is already sorted by the column that you are grouping it by. Because conceptually, at one point, we had a table today where we had all of one author's rows at the top, the next author's rows in the middle, and the third author's rows at the bottom. So that table is already sorted by the author's name. When we group that table by the author, then all we were doing is kind of draw an invisible line between the authors so that certain functions like sum only operate within that group. We could randomize the order of the table where each of the authors appear in random order. Group by still works because it's not really invisible lines. It's creating buckets, and it will create one bucket for every unique value in the column you tell it. And in the bucket, it throws the row numbers of all of the observations that correspond to that author or that unique value. That's really what's going on behind the scenes. Anti-join. When you anti-join two tables, it looks for matches between the tables. In our case, we had a table of our books that had a word column. We also had a stop words table with a word column. The anti-join command looked for matches in both of the word columns, and when it found matching words, it deleted that row from the original table. If our original table had a row with the word "the" in it, it's going to match with a row in the stop words table that had the word "the" in it. When it found that match, it deletes that row with "the" in it from our books table. We use anti-join to remove those stop words from our table. Stop words are words that don't have a lot of value for our analysis. I didn't get into this much, by the way. However, the stop words table that we used that came, I think, in the tidy text package, it included a few lexicons of stop words. And the correct lexicon for your data may not be the lexicons that came with the tidy text package. What I strongly encourage you to do is before you ever use stop words, make sure you are using the correct stop words lexicon for your data. If you were analyzing Twitter tweets, it would probably be a remarkably different stop words lexicon appropriate for that than if you were, say, using stop words on Charlotte Bronte. Make sure you're using the right stop words lexicon for the data that you're analyzing. ggplot, we'll go over that on session 3 in 2 weeks. It's an awesome library of visualizations or visualization tools. And it is a critical part of your ability to convey your output or express your output to decision makers. You almost always have to be able to create visualizations. Gutenberg download is a great function we use to download books from Project Gutenberg. Bind rows, that took multiple tables and just slapped them. It just stitched them together one after another. Pound, I don't know how much it went into that. Pound, anywhere in a line of code, tells R to ignore everything after the pound. It's a comment. As R is processing your code, as soon as it hits a pound, it stops processing the rest of that line. You will often find the pound sign at the beginning of a line for a formal comment, but sometimes you'll find it in the middle of the line. It's okay. All it means is, hey R, stop try and interpret this line because the rest of the line is just text I've written. It's not meant to be code. It is handy to put comments all over your code for two reasons. So that the future you can remember what you did. And that is more important than you think. You need to put comments for any code that's not supremely obvious, again, so that the future you can know what were you thinking. Additionally, if you share your code with others, which you should expect to do if you're a researcher, so that others can reproduce your results. If you share your code with others, these others need to understand your thinking also. Comments are very useful. And finally, the tidyverse. R itself is a language from about 20, 30 years ago, and actually derives from a different language called S+. It has a long history. Recently, let me back up. R and S+ are really from the statistics world and some related disciplines. R has evolved to be highly relevant to other disciplines, such as text mining and others, and it's the tidyverse that has done the most work at cleaning up some weirdness with R and broadening its use well outside of strictly statistics. And that is one advantage R has. I don't want to get into religious war, but that is one advantage R has over Python. Python has a lot of strengths, but a challenge of Python is if you want to do what we did today, you could do it, but you first have to choose between a lot of competing libraries. Whereas with R, the world is generally converging around the tidyverse as the right way of doing things. So while you do have mainly one choice with R, it's a good choice, it's a great community, and it's evolving very well. Next are the cheat sheets. I think these are really useful. At the RStudio website, you can just search Google on RStudio cheat sheets. There are quite a few cheat sheets that will help you with your use of R. These get into advanced topics. Here's one that could be useful, is the RStudio IDE. This is a cheat sheet that just explains how to use RStudio and what the various parts of it mean. These are meant to be printed, and if you happen to have a large format printer like 11 by 17, that's really the ideal format for these. These are still really handy references to have available in case you want something to jog your memory. R Markdown. I see two of those. Interesting. There's R Markdown cheat sheet and R Markdown reference guide. Huh. Data visualization. When we go over ggplot on the next class, this could be a very handy cheat sheet to help you extend your knowledge beyond the introduction we have in class. Stack Overflow. There are a lot of great resources to find help if you need help on how to write R and how to do things in R. 3 things I want to say about that. First is, again, Stack Overflow. I mentioned that because there are several sources for R that are great sources. However, I feel that Stack Overflow is the best of all of them. It's just the most comprehensive, has the best community, has a great community, easiest to use, and it just does a good job overall. The second is that it is normal for software developers to seek help. There is no such thing as a software developer that has all the answers. The field is so complicated. I'm a professional in the field. I have a computer science master's. I have 20 years of experience in this field. I am all the time searching out answers on the internet. No one. There's no unicorn out there that is so good as to have all of the answers available immediately. It is normal and customary to validate your approach to things or even figure out your approach to software or coding issues by searching the internet. The third is, as I say on the screen, watch for old posts. What I mean by that is the tidyverse has really taken hold in the past decade. But even then, it's been a ramp up over the past decade. Watch for older answers to questions on Stack Overflow or wherever that give you a pre-tidyverse explanation. They may send you down a path that isn't very helpful. So watch for answers that you are confident are giving you the tidyverse way of doing things. One thing I didn't get too much into is I said Tibble a lot, but there's also the concept of a data frame. I think I mentioned, yeah, Tibble and data frame. The data frame concept comes with original R, and the Tibble concept is an improvement on the data frame that was delivered with the tidyverse. If you have a data frame, you can usually use it in Tibble functions, and if you have a Tibble, you can usually use it with functions that expect data frames. They're usually compatible. There's still some differences though, where if you want to find out how to do something and the answer expresses how to do it with the data frame, then you may get a more complicated answer, or you may get into some stuff that's unnecessary or counterproductive. So what I'm trying to get at, it's just reinforcing the point. Watch for old posts. Try to stick with the newer post, and make sure that the answer you are seeking out, if feasible, is an answer that is based on the tidyverse. Vincent asked, can you say anything about why someone would use R Markdown versus R script? Great question. The short answer is that, and this is something I may modify things a little bit. The fifth session, the last session of this, is supposed to be about topic modeling. That kind of goes fast and it's a little bit weird. What I may do instead is go deeper into R Markdown. I think that's an unappreciated, there's a better one. It's an underappreciated part of describing yourself. So R Markdown, this is our Markdown file I have up here. It is a combination of Markdown text and R code, and it's not in this one, it's in this one actually, and some configuration, YAML configuration at the top. Don't get scared, it's easier than it looks. But it's a great way to help you produce outputs that can include visualizations, limited view of data, like you see here. Like we have an attractive looking table with some data in it, and your own text. And what happens is you knit the R Markdown into a file format you like, and in many cases the HTML, but you can also do PDFs or Word documents or other formats. Let's see if this thing breaks. There we go. So then you knit your R Markdown into output that you can then use to share with decision makers if you'd like. We'll talk more about this hopefully on the fifth class. I think R Markdown is very useful, and I think it probably could be condensed down to maybe about an hour of instruction. But thank you for asking that. If you ever heard of Jupyter notebooks, almost the same concept, just implemented on a different platform. Jupyter notebooks are for languages, nominally for the languages Julia, R, and Python. The reality is Jupyter notebooks are more focused on the Python community, but they can't put R into it. R notebooks are more focused on the R community, but they can support Python. So there's some cross-platform stuff going on here. And just like with everything in this class, the concepts you're going to learn are pretty cross-platform compatible, meaning that if after this class you say, you know what, R is not for me, I want to learn Python or Julia or some other language, you're in a good position, because the concepts you're learning in this class will accelerate your ability to pick up any other language. Next is chapter 2 of text mining with R, which is the chapter about sentiment analysis. And by the way, we'll take a break at 10:30. We have about 24 minutes until then, so let's get moving. I am going to clear out my information from chapter 1. These broom icons, you click on them, they'll clean up the objects and graphs and everything. So it is a way you can help reset stuff. Close these out because they're no longer valid. Sentiment analysis. Sentiment analysis is where you can get. I watched a video of myself from chapter 1. I was embarrassed at how much I said I also said so. I'm realizing I'm using a lot of buzzwords or filler language I need to stop doing. It's hard to think about it, but I'm trying. If I start saying or so a lot, unmute yourself and stop me, or raise your hand, or embarrass me. I need to know. Libraries. The first thing we are doing is loading the. Did someone say something over chat? Yeah, someone did. My wife is a hawk. Thank you, John. My wife, I said again. My wife doesn't really notice it, but I do know some others, some colleagues that tend to say quite a bit. I need to stop it. Oh, do we have chapter 2 material? Oh my gosh, we do. And let me share it with you right now. I have all this in OneDrive. It's a demonstration and chapter 2. I will share it with everybody over the chat window. Give me a second. I'll give you a link. Thank you for asking, Elena. Copy. Whoops. Copy. I will email it to all of you right now. I'm not sure if you can capture what I put in the chat window. Just might look, here it is. Sorry that I forgot this. Oops. I will give you a little bit to receive the email, download the file, and get it loaded in R. I'm trying to pull up a musical interlude. I'll give you about a minute.
Yeah. Some of you might be wondering, how exactly does one beat?
While we're taking this minute, I'm gonna catch up.
Take it away, Gabe.
Throw your hands up, then point them to the floor. Here's what to do, now get down on all fours. Just bounce around, it's easy, follow me. Go crazy now, and beep beep like a sheep. Beep beep, I'm a sheep, I said beep beep, I'm a sheep. Beep beep, I'm a sheep, I said beep beep, I'm a sheep. Beep beep, you got to beep beep. I said beep beep, I'm a sheep. Beep beep, you got to.
Do we have it loaded? I'm gonna assume you've had enough time to download the file and get it loaded into RStudio. And while we were waiting, I said again. My adult soccer team's kind of freaking out because we've only been able to play 2 games, and it looks like they're going to take the soccer season into the summer. Actually, we're not freaking out. It's just we want to play. We're sick of waiting around, but we understand we need to wait until it's safe to end social distancing, which may be a while. Chapter 2, sentiment analysis. Let's get started. The first line loads the tidy text library. Tidy text library is not loaded when you load the tidyverse. The tidyverse library loads, or sorry, the tidyverse package, when loaded, it loads 8 different packages, but let me verify this. I think that's right. Restart R. Restart R to clear out what I've done previously. So here I'm reloading the tidyverse. Correct. The tidy text package is part of the tidyverse, but it is not one of the 8 packages that is loaded with when you load the tidyverse library. They have some funny names. They have the per library and then the for cats library. Teehee. Restart R again to give me a clean R. Line 1, load the tidy text library. That will give us the sentiment analysis stuff that my computer's running slow. Oh, it's because I'm recording and share my desktop with Zoom. That's why it's slow. And then OneDrive's being stupid. This is a fairly beefy i7 laptop. I don't know why OneDrive's doing that. Whatever. First step of this chapter is let's look at some sentiment lexicons and explain a little bit about them. As I said on the prior chapter, with stop words, you have multiple stop word lexicons you may choose from as you are analyzing your data. You must choose the correct stop word lexicon for your data. And the stop word lexicon you might choose for Twitter tweets is probably going to be different than the lexicon you choose for Jane Austen. Make sure that whatever lexicon you use is appropriate for your data. The same goes for sentiments. For sentiment lexicons. Sentiment lexicons, you must choose the right sentiment lexicon that works with your data. There are 4 sentiment lexicons that are directly supported by the tidy text package: AFIN, Bing, NRC, and I always mispronounce this, and Dr. Fomby will tell me the correct pronunciation. I say Luran, but I think it's Lauren or something different. I forget. They have different ways they were compiled and different intents, such as this last one, Lauren. It is meant for analyzing financial, economics, business documents. So you would not use this sentiment lexicon on Jane Austen. What I also think is funny is at the end of this guy, he has superfluous words. And what bothers me is how many of these words I use. Ugh. I need to improve my vocabulary. And a funny one is superannuation. In the United Methodist Church, superannuation is what is their term for you're too old to preach, you have to retire. I think it's at 72 years old now. So at 72 years old, you have to retire as a pastor. But they still have some loopholes where if you still would like to be a pastor, they could find some part-time gigs for you. Or if there's a church they just can't find a pastor for, you could go work full-time at one of those also. The point, though, is this particular lexicon is really meant for analyzing financial documents. I have some links to the right of these other lexicons. NRC is interesting because it even classifies emoticons. And that's not the right place. I do not know where it is. I think I've linked to the wrong thing here. Somewhere you can see where they assign sentiment scores to emoticons. Let's go back. Oh, here it is. This is the one. This AFIN lexicon, its data is on GitHub, and here we go. AFIN uses a score of -5 to 5 to express the sentiment of every word or emoticon, to say how negative or how positive of a score it is. For any negative, oh wow, so if I put this many whatever lips on my smiley, I get a more positive score than if I only put 2. Is there a -5? No, there's no -5. And it's hard to see if there's a +5. You see some variants. Oh, XOs. That's lots of kisses, a few kisses, a happy face of big eyes, a sad face of big eyes. Kind of funny. Let's look though at the AFIN. Here it is. Here's the AFIN sentiment lexicon. It has -5 through +5 scores applied to each of the words. Being a little bit different, it just lists positive and negative. So it doesn't run -5 to +5. It's just positive or negative, kind of like 1 or -1. The next one, NRC, has a positive or negative, but it also has a kind of emotion. Abandon connotes fear, but also abandon connotes sadness, and it's a negative emotion. Generally, the words have a negative or positive, although there are some cases like abacus, which they're saying is neutral on negative or positive emotion, but it still expresses a trust sentiment. Next, we will load a few more libraries to get the Jane Austen books again. And we are loading 2 libraries that are part of the Tidyverse. If it was me, I just would load the Tidyverse. But for this example, the author decided to load 2 libraries that would have been loaded by the Tidyverse package separately. Whatever, that's fine. Okay, I need to unpack this command, and I will do it in another window. The first part of this pipe, excuse me, is Austen Books. We learned that one at the beginning of the last class. That simply returns a tibble that has a row representing the line of the book and the book's title. 2 columns. It's not in a tidy format unless your intended analysis is a row of text as it appeared in an original book. If that's not your intent, then this is not tidy. Next, we group it by book. So we create those buckets, 1 bucket for each unique value in the book column. And in that bucket, we put the row numbers, excuse me, for each row that corresponds to that unique value. So for the bucket named Sense and Sensibility, we put the numbers 1, 2, 3, 4, 5, etc. We put all the row numbers where the value of the book column is sense and sensibility into this sense and sensibility bucket. And I'll show you something. There's the output of that. You again can't really see anything, although it does say, okay, we now have a group on this table, and we found 6 unique values. There is something called the attributes function. And attributes shows you some behind the scenes information about the object that you give it. In this case, the object we're giving it is the output of these 2 commands, which will be a tibble. And here we go. There is a groups attribute. And look what I said. There's a bucket corresponding to each unique value of the book column. And in that bucket is a list of the numbers of the rows that have this unique value in the book column. That's how it works behind the scenes. This is going to be a little bit more complicated command to unpack. This is the 3rd command in the pipeline. Who can remind me, what does the mutate command do? It looks scary, but it's simple. What does it do?
Create a column.
That's a column.
Yes, it adds a column. In this case, we are adding 2 columns. The first column will be named line number, and the value that we are assigning to it is the current row number of the line that we're on. However, the row number function is sensitive to the grouping. The row number counts will, what is this? Sorry, this is I gotta watch these sometimes. Oh, never mind. I don't worry about that. I'll get those kinds of notices when one of our web servers is down, and because electronic communications are so important, I get a little bit jumpy on some of those notices. That was not a outage message. Again, what happens is the row number function, it will first count up all the rows in Sense and Sensibility. Then when it encounters the first row in Pride and Prejudice, it resets back to row number 1. And he'll do that again for all these books. So the row number function is sensitive to the grouping. It will reset its calculation when it hits a new group. It's a spiffy feature. The next is we are also adding a column named chapter. And what chapter, the value of chapter is going to be the output of this function, which is the cumulative sum function. And what the cumulative sum function does is it waits until this expression evaluates to true. And what does that expression, whoops, I think it's that. What does that expression do? This is a use of the string detect function, is detecting for where at the beginning of the line, this, by the way, this is a regular expression. This is really beyond the scope of this course, but they're really handy things to learn. This is a regular expression. And what it's saying is this caret character, that means start at the beginning of the line. It means whatever you're matching with this pattern must be at the beginning of the line. I'm looking for the word chapter. Whoops. I'm looking for the word chapter, and then a space, and then any one of these characters. And where are these characters? This first one is an escaped character, but it means give me any number 0 through 9, or an I, or a V, or an X, or an L, or a C. And why these last ones? These are Roman numerals. So it is looking for the word chapter, a space, and then one digit of a ordinary number or of a Roman numeral. Once it finds that, then this returns true, and then this increments the sum by 1. So at the beginning, on the first row, the cumulative sum function will return 0 because this string detection has not found the pattern it wants to find. So cum sum is 0, 0, 0, and so on until it reaches here. Oh, look at this. At the beginning of the line, we do see the word chapter, followed by a space, followed by a number. Aha! When that happens, this highlighted function will return a true. I did match the pattern. And when that happens, the cumulative sum function is going to start returning a 1. And it'll keep returning a 1 until the next time that pattern is matched, which in this case will be chapter 2. Then it'll start returning 2 because we've matched the pattern again. So the cumulative sum function is returning simply the number of times that this thing matches the pattern, or really returns true.
I have a quick question about
Yeah, go ahead.
how group by is working. So I assume that in this case, because the books have individual Project Gutenberg IDs, that's how it's breaking them up. But if you had to do a group book or a group by task by the line book, and you're using string detect to search a pattern, because you're working with something like Paradise Lost or the Iliad, and you want to go book 1, book 2. The problem that I have specifically, and maybe we'll get to this, is what happens when that pattern starts reoccurring in endnotes, because we don't want those in analysis, but we do want the text of the actual books.
Yeah.
But in this case, we can use string detect to find books in something like Paradise Lost or the Iliad, without having to force the RStudio to work through Project Gutenberg IDs to group books, right?
Ultimately, well, let me first address something that you mentioned. In this case, we are not using Project Gutenberg. I'm glad you asked this. So thank you for asking.
Austin books. But...
Yeah, we're using the Austin Books tibble. And the output of the Austin Books function is this tibble, which has a book column, which simply contains the, excuse me, the name of the book we are analyzing. And then it contains a text column, which is simply row by row, the contents in some original printed version of this book. I don't know which version, but some version. This is the literal printed rows you would see in the book. That's what we have to go by. Those, you can only group by data that actually appears in the tibble. In this case, the only data it makes any sense to group by will be the book column. So I think what you're getting at is you're saying, well, I may have a different way I need to group my information.
Yeah.
If that's the case, you will need to somehow find a way of adding an additional column to represent the data that you're going to group by.
So
And let me
through
be
the
clear.
mutate command, you could add a column, make
Yes.
that column books, and then give string detect a way to find book 1, book 2 with the Roman numerals, and then it'll break it up that way.
You could. Now, group by will group it by the unique values in the column you have specified. So it doesn't have to be numeric. It doesn't have to be 1, 2, or 3. But as long as it's any unique value, it will
Right.
then group by all the detected unique values.
And then
When
I
I
see
show,
here we have books and chapters. Is that a way of saying that it can look for the book at the first level and then organize at a second level the content by chapter?
if you wanted to, the group by function can take multiple arguments. Let's suppose that the output of um, the output of these commands does result in this. So it results in this table as a text, book, line number, and chapter column. Let's suppose you wanted to not group by book, but group by the book and the chapter. Then the way you would do that is in your pipe, you'd have a group by command. You would say book, chapter. Then what happens there is the group by command looks for all unique combinations of the values in the book and chapter columns, and it creates a separate group for each. So it will have one group for chapter, in this case, 0, but I mean, whatever, it's a unique value. It'll have one group for chapter 0 of Sense and Sensibility. It'll have another group for chapter 1 of Sense and Sensibility, and so on. Then they'll have another group for chapter 0 of Pride and Prejudice. They have chapter 1 of Pride and Prejudice, ... They have another group for chapter 0 of Mansfield Park, chapter 1 of Mansfield Park. Does that get to where you're asking?
Yes.
Okay.
Mhm.
Ultimately, group by is going to operate off of the columns that actually exist in your table, and it will group by the unique values it finds in the column. And if you specify multiple columns, then it will group by the combinations, every combination of the unique values in those multiple columns you have specified. Is that good?
Yes. Thank
Okay,
you.
sure. Yeah. So I think the ultimate answer for you, excuse me, is you have to make sure that whatever you wish to group by, there are columns that exist that you want to group them by. Okay?
Thanks.
Thank you for asking. It is 10:30. Let's go ahead and take our 15-minute break now. I'll play some crazy music and we'll get back here at 10:45. See you in a few minutes.
One, two, three,